So today we're going to look at proving lines parallel. So basically what we looked at on Friday is that whenever we have two lines cut by a transversal, they create a bunch of different types of angles. And so what we're going to look at today is how we can prove lines parallel based on that relationship, and how based on the relationship we can find different missing angle measures. So let's just go ahead and dive right in. Before we do that, I just want to briefly review what we went over on Friday. We looked at different types of angle relationships. And what I'm going to go over right now is the alternate interior angles theorem, the alternate exterior angles, same side interior angles, and congruent angles. So alternate interior angles were interior angles on alternate sides. So they have to be interior, and then they're on opposite sides, or alternate sides of the transversal, so 3 and 6, 4 and 5. And what we learned about the relationship is that these are congruent to each other. So that is alternate interior angles. We also learned about alternate exterior angles. So exterior angles are going to be exterior angles. Oh no. And they're going to be on alternate sides. So 1 and 8 and 2 and 7. And we learned that those are congruent to each other. We also looked at same side interior angles. These are angles, and first thing, interior angles. Then these angles are on the same side, so 3 and 5 and 4 and 6. And what we learned about these is that these angles are supplementary, so if you add them together, they have to equal 180 degrees. And that's same side interior angles. And lastly, we looked at corresponding angles. Corresponding angles are just corresponding sides. So 1 and 5, 2 and 6, 3 and 7, and 4 and 8. And what we learned about these is that these are congruent to each other. So if for some reason you're unsure about why these things are congruent to each other or why they equal to 180 degrees, I would go ahead and review the PowerPoint that we went over on Friday, because that's kind of what we reviewed. Whenever we have two lines cut by a transversal, they create different types of angles, and those different types of angles have special relationships. For example, they're congruent to each other or they're supplementary to each other. Okay? But what we're going to be able to do today is we're going to be able to look at these relationships, and given that these things are true, what we'll be able to prove is that the two lines that are cut by a transversal are parallel to each other. So what we're going to see here is a bunch of different theorems today, and these theorems are going to be in the form of conditional statements. So if hypothesis, then conclusion. And what we're actually going to see is we're going to be able to identify how we apply a conditional statement and how we apply its converse, and what that will tell us about the relationships between these things. So the corresponding angles theorem stated: if a transversal intersects two parallel lines, well, then the resulting corresponding angles are congruent. So if parallel, then those corresponding angles are going to be congruent. What the converse of that does, it says if congruent, then parallel. So if we do in fact have two lines cut by a transversal and the corresponding angles which are made out of those two lines are congruent, well, then what we'll know from that is that our lines are parallel. So this one, it reverses it and it goes if congruent, then parallel. Okay, and what we're going to see today is that all of these different theorems that we looked at on Friday, you can use the converse to prove that those lines are parallel. So basically, we'd use the converse of these theorems to prove lines are parallel. Thus, today, proving lines are parallel. We also have the same side interior angle theorem, which basically says if a transversal intersects two parallel lines, so if parallel lines, well, then those same side interior angles are supplementary. While the converse says if those same side interior angles are supplementary, then parallel. The alternate interior angles theorem states if parallel, then our alternate interior angles are congruent. The converse of that states if our alternate interior angles are congruent, then those lines are parallel. Alternate exterior angles, if they're parallel lines, well, then the alternate exterior angles which are created will be congruent. The converse will state if there are alternate exterior angles which are congruent, well, then those lines must be parallel. Okay, so basically what the takeaway today is that we have these different angle relationships, and what we're able to do with these different angles relationships is we're able to prove that two lines are in fact parallel based on the converse of those relationships. So yeah, so basically if I were told, if I didn't, okay, say that I had these two angles and I was told that they were both equal to 30 degrees. And then I was asked, well, are these lines parallel? Well, what the converse tells me is if those two corresponding angles are in fact congruent, then they are parallel. Same thing here. If I'm told that 1 is equal to 80 and 100 is equal to 20, and I know that these are same side interior angles that are supplementary, because 80 plus 100 is equal to 180. And then I'm asked, based on that relationship, are these two lines parallel? What I'd be able to say is yes, according to the converse of the same side interior angles theorem. Same thing here. If I know this is 40 and this is 40, and I know that they're alternate interior angles, and then I'm asked, are they parallel? Based on that, what I'm able to say is yes. Lastly, we have this one. If this is 70, that is 70. They are congruent to each other. They are alternate exterior angles, so are they parallel? Yes. What we can do with the, not the converse of that, but the original of that, is basically I'd be able to identify, because these two lines are parallel, I know the different relationships, so I'm able to fill in the missing parts. So because parallel, then the corresponding angles must be congruent to each other. And so because of that, and given that information, what I'm able to do is I'm able to solve for all the missing angle measures. And so basically what I'm able to do there is, because I know corresponding angles, because I know these are parallel and I know that the resulting corresponding angles are congruent, I'm able to solve for the rest of my angles. So you can kind of see the difference of going back and forth. So say that I'm asked to find the unknown measures of this diagram right here. And I'm told that the measure of angle 4 is 60. This is 60. Well, it says if the measure of angle 4 is 60, then what are the measures of the other angles that make Q parallel to P and N parallel to M? So basically, what I'm trying to identify is if these things are in fact parallel, am I able to find the missing angle measures? And the answer is yes, you can. And so the first one I'll look at is this one and this one. That's cut by this transversal. And so based on that, I'm able to find the missing angle measures, my vertical angles. These angles are supplementary, vertical angles, corresponding angles. And that allows me to solve for my angles. This is 120, and this is also 120. Oh, this is 60. So basically, because parallel, I'm able to use my different theorems to solve for that missing angle theorem. Now, what about 1? How do I solve for 1? Well, and now I'll just do this. Now, these two are parallel to each other, and this is the transversal. And I've already solved for 3, and I've already solved for 2. And so because of that, I want to look at what I have here. And what I have here is alternate exterior angles. And that relationship helps me solve for 1. And I could actually go ahead and solve for all these if I wanted to as well. Okay, so based on the fact that these lines are parallel, what I'm able to do is solve for my missing angle measures depending on the type of theorem that I have, or depending on the relationship of these different types of angles. Okay, any questions here? Questions, concerns? No? Okay, say that I had a problem like this. What you'll see here is the diagram's a little bit different, but I went ahead and kind of simplified it for you. But basically what it's saying is, are you able to find the value of x and y that would make line Q and that would make line G and G parallel to line H? So if I'm trying to make line G parallel to line H, I need to use the converse of these things. And basically by using the converse, I know that if these certain angle relationships are true, well then those two lines would be parallel to each other. So how do I find x? Well, I find x by identifying that this missing angle is 60. And the reason is that because that angle and this angle form a 90-degree angle. 90 minus 30 equals 60. Okay, so that allows me to find 60. Now what information I'm given is I have my G, which is parallel to my H. And if this is the transversal, then the relationship here, I have alternate interior angles, and the relationship of alternate interior angles tells me that those two must be congruent to each other. And so because of that, 60 must be congruent to 3x. X is equal to 20. So that's how I'm able to solve for that. Now, what if I'm looking for y? Well, if G and H are in fact parallel, and if this line is in fact the transversal, and it intersects those two parallel lines, then the relationship I should be getting here is my corresponding angles theorem. And my corresponding angles theorem basically tells me that those two must be equal to each other. And how I got 150 is I added 60 plus 90, because that's my angle measure, this angle measure right here. And that's being compared to this angle measure right here. And so 150, if it is corresponding angles, then they must be congruent to each other. So y is equal to 75. So basically what this is saying is that if these lines are in fact parallel, then what I should be able to do is identify these different angle relationships. And here we had alternate interior angles relationship, and we had a corresponding angle relationship. And that is only is true if those two lines are in fact parallel to each other, if G and H are in fact parallel to each other. And G and H being parallel to each other is this line is parallel to this line. Yeah. Any questions here? So basically what you're able to do from that diagram is you're able to create those parallel lines and the transversal to make it easier for you to see what the relationship between those two angles are. Okay, but like always, we'll go over some practice problems tomorrow, but basically what you should be able to understand today is that we use the converse of these different theorems to prove those lines are parallel. But if we're told that those lines are parallel, then what we're able to do is identify the missing angle relationships. Okay? All right. If there's no other questions for today, we'll go over some practice problems tomorrow. But yeah, I'll see you guys tomorrow. Bye, guys.